Welcome to the Machine Learning for Digital Advertising AWS webinar. Machine learning is one of the topics we are asked most frequently by our digital advertising customers. In this session, we will discuss some of the specific machine learning challenges faced by advertising players and also discuss some of the methods for simplifying the machine learning process. I'm Dmitry Chikatilov, Global Business Development Lead for AWS Digital Advertising Business. Let's begin. Machine learning is everywhere in the digital advertising industry. Across all elements of the advertising value chain, we've seen customers adopting machine learning techniques to find ways of improving performance, especially important in the current margin-compressed environment. Three of the most common use cases focus on improving advertising campaigns. This includes a number of techniques for finding the most likely buyers, including audience targeting models and lookalike modeling. Maximizing the return on the ad spend through channel analysis is another very common use case. Here we see customers using machine learning in their channel attribution systems and for multi-channel optimization. Customers are also using machine learning to combat ad fraud discovered in their systems. As the amount of fraudulent traffic grows, this use case is becoming more critical. In addition, we see customers using machine learning for a wide variety of use cases that drive business outcomes, including traffic shaping, identity enrichment, campaign pacing, bid evaluation, and many others. So, if machine learning is central to digital advertising, why are we seeing many customers still very early in their machine learning journeys? Across the digital advertising value chain, we see challenges with the adoption of machine learning. Generally, these challenges fall into three buckets. First, and most important, data preprocessing for machine learning is very laborious and manual, and particularly so in advertising industry. Given the massive data sets that many advertisers work with, just getting data into a suitable condition for machine learning training can be very challenging. Second, managing infrastructure to host model training and model inference can be also very challenging. We frequently hear from advertising data scientists that this work is not their core competency and that it distracts them from the data science process that they would truly like to focus on. Third, machine learning expertise is scarce. Although some customers of the digital advertising industry are very sophisticated machine learning practitioners, and in some cases, they're near vanguard of machine learning research, many customers are still very early in their machine learning journeys. They may have only a small dedicated data science team, and in many cases, we also find that non-data scientists, such as data engineers, business analysts, and other stakeholders, are actually aspiring to become the internal machine learning experts and going after these use cases as a side projects. At AWS, we are focused on building tools that help customers address these three challenges. The first one is data preprocessing. The AWS Analytics platform helps offload the undifferentiated heavy lifting of data processing that's required to create clean input for all your machine learning processes. Second, AWS provides elastic infrastructure that scales easily to meet even the largest model training requirements. We offer a variety of ways to automate the critical infrastructure provisioning as well. So if you want to focus on just the core data science, you can definitely do that. Of course, everything is open under the hood. If you'd like to also manually customize any infrastructure component, you can do that. And third, we are focused on building some simple frameworks and example assets that help early-stage machine learning practitioners get started. Often these assets can be generic, so we would be focusing on templates specific to the digital advertising industry. Today, we'll talk about 4 areas where AWS can help digital advertising customers, all at stage machine learning maturity. Simplify, automate, and accelerate their machine learning projects. So first, we'll discuss the typical machine learning workflow in advertising. Across all customers, we see common patterns that can slow down the ML process. we'll identify those pain points to focus our discussion on solutions. Second, we'll discuss efficient preprocessing and exploration of the digital advertising data. Then, we'll outline a few strategies for task automation within machine learning workflow. And finally, we'll talk about Amazon Sagemaker, the new managed machine learning service from AWS, which was recently announced at re:Invent. We will discuss how patterns from today's call can be applied to this new service. Now let's get into the details of the digital advertising machine learning workflow. So let's begin by understanding the typical advertising machine learning workflow. So first, raw data. Advertisers are dealing with tremendous amount of it. A typical pattern we observe here is, for example, a digital advertising agency receiving many different CSV files with campaign data, and they come, for example, in Google DoubleClick campaign manager format. Perhaps you are ingesting these logs weekly or even daily with separate log sources for each active campaign. This data requires significant cleansing, validation, and transformation before further data science work can occur. Cleansing and validation can be very complex, but at minimum, typically refers to stripping out null values, malformed log data, obvious errors, and other standard tasks. Data transformation is usually from CSV format to a more data science-friendly format. Parquet is the most common format observed among customers, as well as the other columnar formats such as ORC. A typical pattern observed with advertising customers is that these data preprocessing tasks are performed manually on an ad hoc basis on complex on-premise Hadoop clusters. As one customer put it, quote, "I am the ETL process. ETL happens when I get on Friday and run the batch jobs." Needless to say, this is the wasted time we want to help customers reclaim. Further, for the customers who have dedicated data science teams, these undifferentiated data preprocessing tasks take valuable time and take it away from the actual machine learning experimentation. Okay, so our hypothetical customer, a digital advertising agency working with Google DoubleClick campaign manager data, has now validated and transformed their raw data, and then we have a nice, clean, Parquet formatted data repository. Now we see the customer doing some exploratory analytics to better understand the data set. In our hypothetical example, let's say the customer is interested in building a model to make predictions about customers' purchase pathways. And in order to do so, we would like to first understand what is the average time from the impression to purchase in a given data set. Today, we see many customers performing this analysis by loading all that formatted data into a separate analytics platform. For ad hoc exploration, this is a time-consuming process and actually discourages agile exploration of the dataset. But let's say the customer loaded the data into the data warehouse and has performed the desired queries. Finally, they are ready to import data into their machine learning environment and perform initial training, testing, and evaluation of their models. A common pattern here is to use the Jupyter Notebook format, sitting on top of the underlying EC2 or Elastic MapReduce infrastructure. Structuring an initial model and managing the underlying infrastructure turns out to be a common pain point, particularly for the segment of digital advertising customers who are newer to the ML journey. And next, putting machine learning workflow in production. Once you have a model that has been trained, tested, and evaluated, and you are satisfied with the results, you will employ this model into production, say, into your bidding logic or campaign creation system to make better business decisions. At this point, the model still requires care and feeding, as data features must be regularly refreshed to reflect the latest information. Model accuracy needed to be evaluated. This process can often result in a customer managing an unwieldy set of notebooks and storing features across multiple systems, all of which means more complexity and less time to spend on core business processes. Okay, so let's talk about how AWS platform can help address some of these 4 major points we just described. Let's turn into the uses of AWS platform to address these common pain points. First, cleansing and transforming of raw data. Rather than managing cumbersome batch jobs, advertisers are turning to AWS Glue, a fully managed serverless ETL service, to help automate and simplify these processes. We'll cover some of the specific use cases for AWS Glue in the machine learning process further on. Second, once this data is transformed, ad hoc exploration is simplified with the use of Amazon Athena, which allows query directly against data in S3. In other words, no more separate loading just to perform exploratory analytics. And next, deployment of data science environments. Here, AWS can help with one-click solutions for launching Jupyter Notebook instances on EMR, Elastic MapReduce, or EC2. And finally, production deployment of the workflow. Here again, customers are using AWS Glue in innovative ways to automate the extraction of data features for their production systems. So let's look into what's involved in data preprocessing. As mentioned, the typical process involves cluster management and batch processing to cleanse and transform incoming raw advertising data. What does a simplified workflow look like? Let's walk through a hypothetical AdTech example on the right-hand side. First, the raw campaign data is ingested, typically as a CSV file, to an S3 landing bucket. We can use regular arrival of this data to trigger one or more AWS Glue jobs that automate preprocessing tasks. As a first pass, the data may be first converted from CSV to Parquet format. This is a standard transformation available out of the box with AWS Glue. After initial format conversion, data transformation can be orchestrated with Glue. When AWS Glue creates a data transformation process, known as job, AWS Glue creates PySpark code that is fully editable by the user. These PySpark scripts can be custom created to perform data transformations. The Python code used to perform this transformation can be saved as custom code in Glue, and then set to run on schedule. These Glue orchestrated transformations of advertising data may also occur in multiple data validation or cleansing steps, or tiers. As an example, imagine an advertising agency that orchestrates a series of Glue jobs. First, the raw data set is converted from CSV to Parquet format. Then, the agency may use a second tier of Glue jobs to select only specific columns from the full data set, but only for specific campaign IDs. And finally, the agency may have a third Glue job that encodes custom logic to determine whether a given event should count as a user impression or not. For example, the agency may consider television ads viewed for less than 5 seconds to be non-impressions. At the end of this tier services of Glue jobs, the raw data will be cleaned, validated, and transformed, and now ready for import into the data science process. Okay, so let's turn to the next pain point we had identified, ad hoc exploration of data. As we discussed, the typical advertiser will load the data into a variety of analytical platforms for ad hoc exploratory needs. While these platforms can provide a great deal of functionality for advertising analytics or for data warehousing, they can slow down the process when what we need is really more ad hoc solution. Once we've set up the single or multi-user Glue pipeline to transform our raw data, data scientists will likely to want to understand what shape and feel of the data set, or better to develop meaningful data features and to choose appropriate machine learning model structures. By using AWS Glue for the preprocessing portion of the workflow, Glue will have identified a data schema that Amazon Athena, our serverless analytical offering, can use to access the rest of the data in S3. Athena enables a simple SQL querying of the transformed data to perform the exploratory analytics needed for a robust data science process. For example, many advertising ML models deal with conversion paths, the sequence of events between the initial ad impression and any eventual resulting user conversion events. The advertiser may want to downsample only a portion of the full-time series data to speed up the processing. But to do so, they may want to find the average length of time between an impression and the first subsequent conversion. This type of analysis can be easily performed in an ad hoc fashion with Amazon Athena, providing you a guideline to the advertising data scientists as to what reasonable cut of their data might be. Now let's talk about ways that the digital advertising machine learning workflow can be further automated to remove even more undifferentiated tasks. In a production-grade machine learning workflow, we often utilize data features that are not directly represented in the raw data set. Typically, these features are developed within the data science notebook, for example, Jupyter, and they can be used in one-hot encoders or any other similar classes. While this is an acceptable pattern for initial model training and featurization, in a production-grade model, advertising data scientists may be making regular use of many thousands of features. Often these features are dependent on the intermediate calculation based on inputs from the raw data set. We can better illustrate how this can be done by using advertising machine learning workflow with an example. So let's take a simple digital advertising scenario. In our sample production model, we are using a data feature based on a value that represents each user's single most visited site in the trailing 7 days. This is not typically a standard field in most campaign data formats. In our hypothetical model, we may have a number of data features that all make sense or make use out of this intermediate calculated value. This is yet another preprocessing task that can be automated with AWS Glue, and thus refreshing the intermediate calculation continuously as new campaign data comes in. Later, in the production data science notebook, these intermediate values can be called upon from the S3 resting location. This limits the amount of non-core preprocessing work done in the notebook environment itself, and more importantly, it automates additional data refresh tasks, leading to more streamlined, more up-to-date machine learning models. As an extension of this previous use case is the use of AWS Glue as the engine for building feature repository. Increasingly, we hear from digital advertising customers that they have multiple groups building models based on the same raw datasets, and the wrangling and management of all this data overwhelms the core data science process. We also choose to import common Python libraries into Glue jobs via PySpark editor interface and use of common libraries such as scikit-learn and common classes such as label encoder and one-hot encoder. And they can be done to actually encode the entire process of featurization. As customers advance the internal machine learning capabilities, they may likely use Glue to automatically parallel process a large number of feature extraction jobs from the transformed datasets. This fully automates the building of continuously refreshed S3 feature repository. One or more teams of data scientists can then call upon features in this repository to use it in their various models, knowing that the repository contains the most up-to-date versions of each feature. Okay, so let's see what this looks like altogether. Our raw data lands into S3, where it's then acted upon or triggered by scheduled Glue jobs that perform transformation and custom validation and cleansing of the tasks, as well as data format conversion. No need to guess capacity needed for data processing. Everything is serverless and optimized, and this is very important. Our transformed S3 bucket is accessed by Amazon Athena, which is used both to understand the shape and dimension of the data to inform ML models. It also perhaps can be used by business intelligence users who would like to run self-service queries. A parallel series of AWS Glue jobs automate the data feature extraction from the transformed data and land these data features into S3. These features are then called upon by one or more data science projects, typically hosted in Jupyter notebooks. And finally, production model outputs are stored in S3. So next, let's turn to some of the very newest AWS machine learning services and where they can help publishers and advertisers. Let's spend a moment on Amazon Sagemaker. It's a new service launch at AWS reInvent in November. So what is a Sagemaker? Amazon Sagemaker is a fully managed service for building, training, and deploying machine learning models at any scale. Sagemaker consists of three main components. So first one is authoring, which uses common Jupyter notebook interfaces. Second one is model training, a distributed model building, training, and validation service. And last is model hosting, which consists of HTTPS endpoints for invoking these models so that you can make real-time inferences. Let's talk a little bit about how this service can be used in the digital advertising workflow. First, hyperparameter optimization. Sagemaker automates this typically time-consuming process, helping speed and optimize the experience. In a digital advertising setting, for example, Sagemaker's built-in hyperparameter optimization could be used to automatically find the combination of model settings that optimizes the accuracy of a click fraud detection model. Second, simplified A/B testing. With its model hosting capabilities, Sagemaker simplifies the otherwise very cumbersome process of managing and monitoring performance of multiple models. In the digital advertising setting, you may use Sagemaker, for example, to deploy multiple versions of a customer conversion model to compare performance. And last, access to optimized algorithms. Sagemaker comes out of the box with 10 of the most common machine learning algorithms and uses especially optimized versions. In the digital advertising setting, for example, XGBoost is a commonly used algorithm in the industry for choosing ads based on the surrounding context on a publisher property. XGBoost is used in Sagemaker and provides several built-in performance advantages over non-optimized standard implementations of XGBoost. The same goes for another very popular algorithm of field-aware factorization machines. So we've reviewed a number of tactics for automating and optimizing your digital advertising machine learning workflow. Let's talk a little bit more about some other ways AWS can help you to get started on your machine learning journey. Many of our customers have asked for more prescriptive guidance in setting up their machine learning workflows to match their business needs. For these customers, we offer hands-on ML for Advertising workshop, which is delivered either on-site or virtually, and it can help digital advertising data scientists to learn how to apply machine learning techniques to their business problems. In these hands-on labs, AWS digital advertising experts will guide users through the construction of a sample advertising model to predict user conversion, for example, and then wrap up with a session to identify specific next steps for applying these new learnings to your environment. At the end of the workshop, you will have a more mature data science capability and a specific go-forward plan for your business cases. To register for a workshop, please visit us online at aws.amazon.com/digitaladvertising/ML. Thank you very much for attending this webinar. Again, please visit us online at the above address, and there are lots of resources we're putting online, and we look forward to working with you. Please stay tuned for updates on machine learning and advertising. There are more exciting things to come.